All right, let's take a look at different operations with complex numbers. So the first one, complex conjugates, it's related to when you studied radicals in Algebra 2, how you never wanted to leave a radical in the denominator. So for this, I'm going to multiply by the conjugate. So the conjugate is just changing the sign. So if it was plus, it becomes minus, and if it was minus, it becomes plus. Now, you also, when it comes to complex numbers, you don't want there to be an I in the denominator because technically I is a radical because it is the square root of -1. So this right here, the problem is just a throwback to Algebra 2. Let's take a look at two problems that involve some complex numbers that involve I. For the first problem, I see I in the denominator, so I need to clean that up. I'm going to multiply by the conjugate. The conjugate is 1 minus I, and I multiply the top and the bottom by that. I behaves like a variable. In the numerator, I'm going to multiply 2 times 1, 2 times -I, -7 times 1, and -7I times -I. So be real careful, negative times negative. And anytime you have I times I, it's I squared. Just like x times x would be x squared. Now, the whole rationale behind the conjugate is technically this is the difference of two squares factoring pattern. And we know that the inner and the outer terms are going to cancel. When I look for like terms, I have -2I minus 7I, so I can clean that up. And anytime you see I squared, it is equal to -1. So when I multiply a number by -1, it changes the sign. So pretty much anytime a term has I squared, it changes the sign of that term. 2 minus 7 is going to become -5 in the numerator, and 1 minus -1 will become 1 plus 1. You could write your answer and leave it like this, or you could also separate and put each term over 2. So you could write it either way is acceptable for that. On the next problem, you only have one term, whereas in example 1, we had 2 terms in the denominator. If you only have one term in the denominator and there's an I in the denominator, to simplify that, all you need to do is multiply the top and the bottom by I. So I'm going to do that on number 2 next. I'm going to multiply the top by I, and I'm going to multiply the bottom by I. On the top, I am really technically distributing the I to both terms. 5 times I, 4I times I gives me 4I squared, and 2I times I is 2I squared. Anytime you see I squared, you need to simplify that because we know that I squared is equal to -1. So 4 times -1 will change this to -4. And I want to keep it in standard form. So I'm going to write it as -4 plus 5I. And 2 times -1 is going to be -2. Now, a -4 divided by -2 is a positive 2. And a positive divided by a negative is going to give me a -5 over 2I. So I can simplify my answer and write it like that.